Imagine a world without batteries, no smartphones, no remote controls, no electric cars. But here is the mind-blowing question. How can a teeny metal cylinder or a slim lithium pack create invisible energy that runs our modern life? Today we are going to uncover the extraordinary science of how a battery actually produces electricity. What is a battery really? At its core, a battery is not just a box of stored power, it is a carefully designed chemical power plant in your pocket. A battery does not store electricity like water in a tank. Instead, it stores chemical potential energy hidden inside atoms and molecules. When we connect a battery to a device, that chemical energy is converted into electrical energy, a river of moving electrons. The three key parts of any battery. Every battery, whenever it is in your TV remote or a Tesla, has the same basic anatomy. Anode that has a positive charge when the electrons come. Cathode is the negative side from where the electrons want to go. Electrolyte, the medium that allows ions charged atoms to move inside the battery but blocks electrons from escaping the wrong way. Think of it like this: the anode is like a mountain top, the cathode is like the valley, the electrolyte is the winding path that ions take, while electrons rush through your device like a river flowing downhill. The astonishing chemistry in action. When you insert a battery into a circuit, at the anode, a chemical reaction releases electrons. These electrons are forced to leave and flow through the wire. This is the electricity powering your phone, light, or toy. At the cathode, a different chemical reaction is waiting to grab those electrons. Inside the battery, ions travel through the electrolyte to balance the charge. The entire system is like a perfectly choreographed atomic dance, pushing electrons in one direction only, giving us a steady electric current. Why do batteries run out? Here is a fascinating fact. Batteries die not because they lose electricity, but because the chemicals inside are used up or rearranged. Once the anode and cathode can no longer produce those reactions, the electrons flow stops. It is like a campfire. The fire does not because fire disappeared, but because all the wood is burned out. From ancient fogs to modern Tesla cars, the world's first battery was built 2000 years ago in Baghdad, called the Baghdad Battery. Scientists still debate whether it powered lamps or electroplated jewelry. In the 18th century, Luigi Galvani discovered animal battery when a dead frog's legs twitched from metal contact. That bizarre experiment led to the idea of the battery. Today's lithium-ion batteries power everything from drones to Tesla cars, and NASA even uses advanced versions in spacecrafts. The incredible scale of battery power. A single AA battery can release about 2.8 watt-hours of energy, just enough to run a TV remote for months. Astonishing fact: which battery is the biggest battery on Earth? Hornsdale Power Rivers in Australia. A lithium-ion giant can store over 193 megawatt-hours, enough to power 3,000 homes for a day. But the human body also works like a battery. Your cells use electrochemical gradients to send signals to your brain and keep your heart beating. The future of batteries. Scientists are racing to make batteries that charge in seconds, last for decades, and are safe for the planet. Planet solid-state batteries may one day make electric car drive 1,000 km on a single charge. Nuclear batteries can last for thousands of years. Imagine never charging your phone again. So next time you hold a battery, don't see it as a simple cylinder or a flat pack. See it for what it truly is: a teeny time machine of chemistry, a miniature power plant, and one of humanity's most powerful inventions. Without it, our entire modern life would go dark in an instant.